So imagine a situation where we want to find the height of something. Say this height right here. And we want to know, and we only know some information about it. We know, let's imagine that's a straight line. We know that this angle here is 21 degrees. And this angle here, pointing at the same point at the top of the building, is 24 degrees. And the distance from this point to this point is 50. And the distance from this point to the base is x. This is y. So from this, what can we figure out? From SOHCAHTOA, we can work on the idea that SOHCAHTOA, we can work on the idea that the tangent of 21 degrees is going to be y over y, because this is the opposite over the adjacent, y over x plus 50, or 50 plus x. Because this is the y side of this triangle. The hypotenuse is on this side here. And this entirely, all the way along, is the x. So then, let's look at the other side and say, what would be the tangent of 24 degrees? And on the tangent of 24 degrees, we're going to get the information that y it's just y over x. Y is over x by itself. So that it's from this point for the x and all of the y side applies in this tangent. So we need to move our screen down and recenter ourselves a little bit. So we're going to move downward a little bit, but we're going to take the information that we had, because we need to move this stuff around. We need to move it around so that we're going to manipulate it to equal the y's. So if tangent of 21 degrees equals y over 50 plus x, and the tangent of 24 degrees equals y over x. What can we do here? Well, first of all, let's isolate the y's. Let's isolate it so that y equals, bring this 50 plus x over to this side, because it would cancel if you multiplied both sides. This side would cancel, and then this would be on this side. 50 plus x times the tangent of 21 degrees. And then on this side, we can do a little trick here. We don't need the x's, because we're not trying to figure out the x's. So these x's can be eliminated if we find out what x equals. So we need to flip this. This x can go up and the y can go down. Or we could just switch it. Go with the x over here. So this would eliminate on that side, and this tangent would come to the bottom. Tangent of 24 degrees. So that we know now x equals the y over the tangent of 24 degrees. You see how we did this? This x, if you multiply both sides by x, the x's cancel, then the x is over here. If you multiply both sides by tan of 24 degrees, if you divide by both sides by the tan of 24 degrees, this would cancel out and be on the bottom side here. So now that we know what x equals, Let's move down again. Let's use all the information we have now. Let's write a big equation, because we're going to have a big equation. We're going to have, start with y, because y's can go, you can put the y on either side of this, front or back. Let's start with y equals, let's start big, 50 plus x times the tangent of 21 degrees. But the x right here equals y over tan of 24 degrees. We can take that x right there and replace it with all that right there. So let's erase. We already know we can get rid of this. Let's get rid of this and just move this information down so that it is, let's actually do a different color, and you'll see that it's y over the tan of 24 degrees. Now this is getting a little more complicated, but you're going to see how useful it is to have done that, because now we only have to solve for y. The first thing we want to do is realize that this tangent can go through here. It should be 50 times tangent of 21 degrees, y times the tangent 21 degrees, all set to y. But yeah, let's do that. There's a couple ways to solve this. Let's solve it that way. So y equals 50 degrees times, we're distributing this tangent through these both. Tangent of 21 degrees plus y times, because it just times the top, the tangent of 21 degrees over tangent of 24. Now I see a way to eliminate. The way to eliminate is ignore this. Just imagine it's there, but it doesn't matter right now. This y and all this can work together for us now.